we are given two graphs. Wonderful. G of x and h of x. One's a cubic, one's a quadratic, and they just touch when x equals 1. Excuse me, negative 1. And what that means is that they share a common tangent. Common tangent. So if we just sketch this, we have a cubic and a quadratic. For example, something like that. No. Yeah, that's a bit more clear. So at this point right here, like they share the same point, and if you draw a tangent at that point, it is tangent to both the quadratic and the cubic. Alright, and our task is to find that point. Cool. So before we even approach the problem, let's acknowledge half the alphabet here, A and B, which means we don't actually know the exact equations of G and H. If we did, it would be trivial because we would just graph it and find the intersection point. However here, our first step, or before we find that intersection point, is to find A and B. And the only information we're given is that when x equals minus 1, they have a common tangent. Cool. So what does that mean? So at x equals minus 1, common tangent means that the gradient at that point for both functions is the same. So the gradient of g of x and h of x would be equal. Yeah. And we also know at x equals negative 1, the y values would be equal. Right? Because those functions are just touching, which means they go through the same point. And now you'll notice we have two equations and two unknowns, which means if there is a solution, we can find it. So if you haven't actually tried this problem yet, try go from there, solving those two equations simultaneously. But if you have and you're just wanting to check, let's go through it right now. So let's go equation 1 first. So you'll notice we need the gradient functions of both. So g prime of x, 3 multiplied out the front, subtract 1 from the power, minus ax squared becomes minus 2ax, and the derivative of 6 is 0. And now h prime of x, 2 multiplied out the front gives 4, subtract 1 from the power gives to the power of 1, and the derivative of bx is b. Right, and derivative of 13 is 0. Okay, so now we can use equation 1, so equating those two together, which gives 3x squared minus 2ax equals 4x plus b. However, we know that this happens at x equals minus 1. So let's substitute in minus 1 in for x. So actually, we could have done it here. That might have made a bit more sense. But, you know, no harm's done. So at, well, actually, yes. The reason why what I've written doesn't actually make sense is because g prime of x isn't equal to h prime of x for all x values. It's only equal at x equals minus 1. So just to backtrack a little bit, we would find g prime of negative 1. And h prime of negative 1 before we can equate them. So what does that become? 1. So 3 plus 2a. And this becomes negative 4 plus b. Alright, so now we can equate them, because from the start we know that the gradients will be equal at x equals negative 1. So 3 plus 2a equals minus 4 plus b. Alright, cool. So we have used equation 1. Now looking at it, I see two unknowns in one equation, which means we can't solve it yet. So let's find the second equation. So equation 2, let's evaluate g and h at x equals negative 1 and then equate them. So this is the original functions, not the gradient function. So at negative 1, cool, and h of x, or h of negative 1, 2 times negative 1 squared plus b times negative 1 plus 13. Alright, and simplifying both of those, we get negative 1 minus a plus 6, which is 5 minus a. And then for h of negative 1, 2 minus b plus 13, which is 15 minus b. Okay, and now we can equate them. So 5 minus a is equal to 15 minus b. And again, this is one equation which has two unknowns, so we can't solve it. However, if we consider our system of equations, we have two equations with the two unknowns a and b. So we can solve them simultaneously. Just to format it a bit more nicely, what we can do is just rewrite them like so. So I subtracted b, and then I also subtracted 3. So the variables are on the left and the constant is on the right. And I'll do that with the bottom equation as well. So minus a plus b equals 10. Cool. Now I will just write those equations one on top of the other. Nope. Or I'll bring this one down here. Cool. So here is our system of equations. Many different ways you can solve a system of equations. I'll use the elimination method. So what that means is we're trying to add these equations in a way to eliminate one of the variables. So I see that we have plus b and minus b. So if I added those together, the b's would cancel out. So I will add each term. So minus a plus 2a gives a. Positive b plus negative b gives 0b. And then 10 plus 7 gives 17. So we're left with a equals 17. Is that right there? Please hold. Minus a plus b, yeah. Oh, classic, right? That little negative sign. Seriously, I've lost so many marks in my mathematics history because of that one little dash. So let's try that again. So 10 plus negative 7 gives positive 3. So A equals positive 3. Now to find B, we substitute into either equation and solve for B. So I'll just use the first one. So minus A, minus 3, plus B equals 10, which means B would equal 13, adding 3 to both sides. Alright, so we found A and B. Now, is that what the question asked us? No. It asked us to find the point of intersection. So, to go about that, I will choose h of x, as it's slightly simpler than the cubic. And we know what b is. B is 13. And we know that they intersect when x is negative 1. So in for x will go negative 1, and we will work out the y value. So we have h of x was 2x squared plus bx, where b is 13, plus another 13, okay? And now we know that they intersect when x is negative 1, so we'll substitute negative 1 in for x. So minus 13 plus 13 cancels. Negative 1 squared is positive 1 times 2. It's positive 2. Therefore, point of intersection is at x is negative 1, y is 2. Awesome. And just to clarify on that, we could have also chosen g of x, right? I encourage you to try that, where a is 3, and when we substitute a negative 1, we should get the y value of 2, right? Because they intersect at that point. And if you have time in the end of your exam, I encourage you to graph both of these once you found a and b on your calculator, and then use gsolve to find the intersection point. Alright, so quite a lot happening with this one, so let's step through it one more time. So we were greeted by two functions that were missing some information, a and b. However, we were told that they just touch when x equals minus 1. So that let us form two equations, right, relating g and h at x equals minus 1. So in doing so, we first differentiated to find g prime of x and h prime of x, so that we could then equate them when x equals minus 1. And so in doing that, that would be the achieved component. But we also formed the second equation, right? G of minus 1 equals h of minus 1. And so in finding both of those equations, that would be merit. And then simultaneously solving for a and b. And then finally finding the point of intersection would be the excellence component. Alrighty, ciao for now.